first experiment in the hardware section of the microprocessor lab is the using logic controller. So the first experiment that we'll be performing is how to multiply two 8-bit numbers read through port B and how to display the answer on port A. So for this we'll be using a control word to configure 8255 in mode 0 with port B as the input and port A as the input. What you are seeing right now in the video is a format of how the control word looks like for 8255 operating in IO mode with mode 0. Just down now. So the aim of the experiment to read the status of 8 bits from the logic controller interface and to display FF if parity is even, else the parity 00 if the parity is odd is the second experiment. So we'll be right now we also have another experiment of how to execute a BCD up-down counter on a logic controller. So currently we'll start with the third experiment, which is how to multiply two 8-bit numbers and to display their result. So here you're seeing the code written down in using a MASM assembler. The logic of the programmers will be using the control word as 82H. So all your inputs will be read through port B having the address as ED01 and the output will be displayed using port A having the address ED00. Now we will be executing this program. So type MASM filename.asm link filename.obj debug filename.exe. So we will be executing this particular program using the trace option. So initially read the control word from 82H and store it in the control word register. Read the first number X, which is an 8-bit number, through port B. Now we'll be showing you how the first number X will be read from the logic controller interface. Initially we are giving the value of X as equal to 000011, which is equivalent to the hexadecimal number 03. Next, we will be storing that number in another register BL in order to save the initial value read of the value of X read from port B should be saved in register BL. Now we'll be reading the second number. And finally, multiplication is performed using the instruction mul-bl, which multiplies the contents of AL with the contents of register BL and stores the result in AL itself. So on the screen you can see that the initial number X was equal to 3, the second number Y was equal to 2, and the final answer that's displayed on the screen is equal to 6. Now this particular result has to be displayed on the logic controller interface also. So we'll be doing that right now. So now you can see that the initial input x was equal to 3, the input y was equal to 2. So your final answer is 0110, which corresponds to the binary value as 06, which is displayed on the logic controller interface.